Okay, we're here. Hi everyone, it's Nono here, and I want to welcome you one more week to the live stream. Today we're going to continue with training Pixel2Style2Pixel, and for those of you who are new or haven't watched any other previous live stream videos, this is a live stream about creative coding and intelligence. So let's get started. I usually let you know that you can support this channel by liking this video and also subscribe and click on the bell to get notified when I go live next or when I upload new videos. You can also join the Discord community where, there's people already joining and collaborating. We're more than 100 people, and I really appreciate many of the pointers that you guys sent at me, and some of the cross collaboration that I see is starting to happen there. Last week we did part 2 of the Pixel2Style2Pixel live 49. I'll remind you also that you can send questions to the podcast at gettingsimple.com/ask, and we're gonna see today continuation of the Pix2Style2Pix or pSp framework training. Let's make an intro to the intelligence and sketching playlist. Let me see if you guys can tell me when you're online, if you can hear me and you can see me okay. It seems like everything looks good. I'm pretty happy with the image that this new setup is giving me, so I'm gonna probably try to have this more often. And let me double check. All right, so let's get started, and I'm gonna stop something here. Cool. Hi everyone, it's Nono here, and the following is another work session part of the Intelligence and Sketching playlist. In this playlist, we're trying to create a collaborative AI drawing or sketching platform in which many humans and bots can draw and collaborate together with artificial intelligences or machine learning algorithms, you name it. Today, the focus is going to be part 3 of Pixel2Style2Pixel. We're trying to see how to train this model because it's not super straightforward. And last week, we were running out of RAM memory, some CUDA error on Google Colab. So today, we're going to continue where we were with the same notebook. I'll link to the notebook on the chat and on the Discord server. And I want to say thank you to Ricardo Cesar Rodriguez. I got this pointer on how we can solve this CUDA memory problem on Discord, and that's what I'm gonna try now. I'm gonna just try to see if this solves our issue. Otherwise, I'm just gonna bump the keyboard until I find a solution, hopefully. If we don't find a solution, I don't know, we'll continue. Maybe I'll try offline, but I wanted to do this here so you see the continuation of what is happening. Okay, without further ado, you can go to previous videos to see some of the things that I showed before on Pixel2Style2Pixel, things that we're building upon, and some content that I have. So let's get to code. All right, no breaks right now, just coding. Okay. So, as I said, I'm going to not open the terminal yet, but I'm going to open a new window here. I'm going to make sure that you can see the entire thing, and I'm going to go to Colab. I believe we linked to this notebook that I'm talking about on Discord, so you can go there to the live channel and get the link. But for me, I'm going to look, well, I mean, I have it here. So last Thursday, we in live 49 we created this notebook, so I'm just gonna go click on it, and we could try to run it to see what error we're getting. I'm gonna clone this, save a copy in Drive, and mainly we're just gonna change the name and continue developing on there. Right, so this is gonna be today's date, and this is like 15. So maybe we can put here, this is V2. And for the previous one, maybe we can rename it to be called v1 for consistency, right? So now we have v1 and v2. And whatever we develop today, so we just save, close that, close that now, and also save this one. All right, so let's take a look. Let me just check one thing here on the side. One and okay. All right, awesome. So let's make this slightly bigger and see. All right, so the first thing I'm gonna do, I'm gonna check that the Dropbox link that we were using to download this dataset still works. So I'm just gonna go into a private window here and I'm going to try to download that file just to make sure that I didn't move it elsewhere. All right, and okay, great. So this is the data set that we're going to be trying to use. It's a really small sample, but the important thing is that the Dropbox link works. And this gets downloaded. I think everything should work as it is. So let's try to connect to GPU runtime. So notice how I go to runtime, change runtime, and I click on GPU high RAM. I can do high RAM because I have a Colab Pro subscription. So that's $10 and taxes plus taxes a month. So my kernel is now connected and we have 26 gigs of RAM or something like that. Okay, so I'm gonna just see, just to catch up, I'm just going to run all the cells and see how it goes. And I'm gonna walk you through the notebook as we see, right? So this notebook is importing the OS library, so the system library, in order to be able to change directory and go to content. We say that the code directory is going to be Pixel2Style2Pixel. That's where we clone our repo, right? So we do git clone. This arrow bang runs this command on shell. So this is not being run on Python, it's being run on shell. Before, for some of the operations, this model, the Pixel2Style2Pixel model, needs Ninja, so Ninja Linux. So this code was provided by the creators of the algorithm, like some code on how to install Ninja. And after the dataset is cloned to that Pixel2Style2Pixel folder, I change to that directory, and from then on, all of the code I have adapted. We have this thing here that I think I remember we didn't really make this work. So yeah, this didn't work. And yeah, we had to fix that, right? Everything else is running. So maybe what we can do, let's try to fix this step. That is what we had missing. So in data here, or in config, right? So the good thing in datasets, so in data, we can see that the dataset has been properly downloaded from Dropbox. So we can say that is working, which is good. I'm gonna hide this stuff. And inside of configs, the file we're trying to change is path config, so paths config. And we're removing the file here. So once we edit this file, no, the paths config, it's empty because something was actually failing. So what I'm going to do here, I'm going to remove rf content pixel to style to pixel. So this is temporary, but we're going to remove and clone again, which is a fast operation. Error retrieving this directory. Can add the parent directories. All right, let's just try to see first where we are. So I'm gonna close this and I'm gonna do ls to list the contents on the directory shell. Error retrieving no such file. Where are we? That's weird. So if we do os change their content, and then we do pdls. All right, so inside of content now we are here. So inside of content, we've removed the directory properly, I think, and we can do git clone. All right, so this could be our place where we actually remove code there. Okay, so what about now? So we have that, and now you know here what's happening. We go to content, we see that we're in content, we have these 3 folders, and then we delete the middle one. And yeah, so now we clone once again. And after this cloning, we can check that now paths config is back in here. So what I'm gonna do, I'm just gonna back up this file until we get the code right, so we don't have to run this delete cell again. So if we have here Pixel2Style2Pixel, we just need to do copy Pixel2Style2Pixel, and that file is inside of configs, paths, config.py. We're gonna copy it to paths config.py in the current directory. All right. So we do here ls, so we see that now we have this file here, and we can even see its contents. No such file. Config. Okay, and that works. All right, so we have backed up that file. We are now gonna get into this directory, and you know what happens if we do this. All right, and we see the files. Okay, great. Can we ls parent? Okay, yeah, great. So what we can do is that every time we run this command, we're gonna copy the parent paths config.py to configs paths config.py. And this is temporary, right? Because we won't be doing that later. And you know, we comment this out. Well, maybe we need this line, so let's try to see if cat. Okay, so it's actually cat configs temp, what we're trying to do. No such file. All right, configs temp. So what is not working is this. Oh, now this is working. Okay, echo. All right, great. So let's quickly try a simple, like changing letters A for letters B and piping that into new.txt, for example, and then cat new.txt. Let's see if that works. All right, that works. So we have changed the letter A. So for example, style gun here. We have, and just to go back a bit, right? What we are doing here is that we originally get this file, But when we clone the algorithm, so the repository explains that we actually have to customize inside of the same repo, we have to customize our config file, right, for the path. So we need to tell it where the select a test and the Flickr faces high quality files are. And that is what we're trying to do with something that's called set, that allows us to do find and replace on the command line. And here what I've said is, okay, now we have all those A's, I just want to convert them into B. So instead of style GAN, we get style BBBN, right? All right, and this is how we do it. So we run the set command and say, okay, write to this other file. And what I'm going to try to do is just to see if the first operation works. And it seems it does. So it's replacing this empty FFQ for this one, right? So we're adding that our data is going to be in data FFHQ, where we're cloning the data. And now we just need the second step. And for that, what we were doing here is slashing again and running this. So slashing again, running this, and doing that line. And I think this might be the character that was wrong. So we do this, we add this part here and run it again. Awesome. So now we have data FFHQ here and here. So it was just a simple typo. So I'm just to verify that that's true. Well, actually it doesn't matter. It probably was just that typo. I'm just going to break the code again. So we want to write to configs paths config, and instead of new.txt, so we remove the temp file afterwards. Okay, so let's try that now. So configs path config.py, and that works. So if we were to not do this step, right, like these steps, what you can see is that the file has these empty things, right? Right now we're copying the empty file from outside. Once we replace it, we'll have to remove the repo and then copy it back again. So what we're gonna do is we just do that, right? So we replace it. And what I'm gonna do actually, just for one, like just copy the original file. So now we see that the original file is in place. I'm gonna copy this copy command, and I'm gonna run this. So now we run this and we have our config and it's replaced. If we keep on running this, nothing happens because the thing that we're trying to find, the string that is this with 2 ticks here, doesn't exist anymore, so nothing happens. So we're good. And when we get this done, I like to go back and start from scratch. We don't need to do this backup anymore, so we can delete this cell. And we don't need to do this either. So what I'm going to do is I'm going to do a factory reset. So factory reset runtime. Yes. So all of our files are going to disappear. The kernel that we're going to get in the back of the notebook is going to be a clean kernel. And, we're connecting to a new runtime. So now we're connecting. We have a new runtime with the same amount of memory, and we don't have our data here. And one thing we could do here is we remove, if it exists, right? We remove sample data. Is that possible that way? It doesn't really matter. Probably not that big. All right, so let's do that one more time. Let's start completely from scratch. Factory reset. And once we do the factory reset, we'll go step by step again, and we'll try to understand everything that's going on. So we did that. We have GPU, high RAM, and let me see. Okay. And let's do a really quick stop here. All right, so let's keep going here. So let's actually clear all outputs and rerun the notebook. So we go to here, runtime, run all, and now we can hide our menu and go through all of the cells once again. Bear with me. We import the OS, change to the content directory and say that our folder needs to be called where we clone the repo Pixel2Style2Pixel. We install the dependencies for Ninja or whatever is required, which we don't really care because it seems like it's working. We clone a repo to the local folder, we change and enter that folder and replace our config. We can see that the contents of our config are properly there. And that we have here, we define a function to download models from Google Drive, right? So we're downloading specifically the pre-trained IR SE50 model taken from Trebian, I guess. And then we download the Facebook Flickr high quality style model, right? This is just a helper that tells us the ID of the file on Google Drive and the name of the file we want to save on our local disk. So I've talked about 2 downloads, and here comes the third one, right? So we have this date function that just provides a date, and that's for the experiment. And here we download the Flickr Faces high quality images from Dropbox. And this is a hard-coded link from my Dropbox, so it downloads it there. And we see that all of the files are being unzipped. And I think we can do unzip Q, right, to avoid seeing all of that, all of this output here. Okay, so now the notebook is training below. And, so far I've talked about 3 things that download, and we're going to see them on disk. So what we can see from here, if we go to data in FFHQ, we have all of the images that we saw at the beginning. So it's 100 images that get downloaded. And then if we go to models, maybe, is it models? Wait 1 second. Okay, let me take a look exactly where we were downloading our models. Oh, pre-trained models. And we have those 2 models that I mentioned are downloaded here. All right, back to the code. And if we keep going down, all we do, well, here this is asking for me to rename all the files. That's a thing. If you don't reset the kernel in this notebook in particular, you're gonna have to replace some of the things that already exist on disk. So that's a bit annoying, but that works. And it seems like it doesn't tell us what's unzipping anymore. But I would say probably we want to do this beforehand. And it is to remove the images that are there. But I'm going to leave that right now. All right, so we're training here, and we're probably getting an error. This tells us all the things that we've set up to train, and we get an error. And we get to where we were last week. This is the same error, same issue that we had last week. And I'm gonna go now. So I guess that is a recap of what we had, and there is nothing here that doesn't work, right? Like everything, every single cell except for the training run, which is the most important, works. And now we're gonna try to see if we can solve this issue. All right, so and yeah, hello. I want to say, let me see where we have the cover slide. This might be confusing to edit later. Well, yeah. Hello to Rob and to whoever connects online, or if you're watching the video afterwards. I will invite you to leave some comments on the chat or maybe comments afterwards on the video. And this is a bit in between things, but I'm gonna say this a few times now. So I'm going to be trying this Substack platform. So if I go to so simply is nono.substack.com. This is where I'm going to start. Maybe I'm thinking of start publishing some of my writing. And if you want to subscribe, you just have to put your email there. So again, at nono.substack.com. And arguably, it's going to be about simple living, creative coding, and intelligence, which is broad enough for me, I think, and what I do. And yeah, so go there if you want to sign up, and I'll put links somewhere else. Okay, so let's go back to this problem. I didn't watch the whole live stream, but I remember being curious about the GPU requirements of Pixel2Style2Pixel. Then I saw the CUDA memory problem and remembered once I was playing around with audio reactive stylegun. There was this code that emptied the cache, freed GPU memory. And yeah, coding without getting errors is not coding. So this is not a link I can click. So I'm gonna go to the Discord server and open that that link. And all right, so that I think was in live, right? Found this yesterday and had some issues trying to find it. Now I can find it again. Okay. Okay, it's here. Oh, I didn't see this memory. So this message that you put here, Rob. Not using a high run runtime, you're using a high run runtime. Yeah, I think I am. I mean, I'm gonna mostly sure that this is gonna show that I'm running a like a high RAM because it's 25 gigs. Your runtime has 27.3 gigabytes. You're using a high RAM runtime. All right, so that's good. Maybe we can put that at the top and crash. If not, maybe. All right, so okay, so let's go down here. What else did we get from Rob? Cannot import model paths from model configs path config. Yep. Okay, so that error not there. Okay, so here. This is a Colab notebook that Ricardo Cesar Rodriguez sent us. And scroll to, okay, so it scrolls to a specific place. Okay, try to enter before each time you run generate. Okay, well, this is Okay, let's try to see that. Let's see if this works. Fingers crossed. 0 of 16. So we have two cards of 16 gigs. And why is TensorFlow, so PyTorch, not able to allocate more? So I guess let's see the memory. Yeah, so thanks Rob. So I think it might be a problem. I don't understand. So let me see. Let's go to the yeah, I didn't post an issue on here. I don't know if somebody probably multi GPU training. We do not support. Should be possible. Please take a look. Okay, so this seems to be our problem, right? Like this is our issue. It says my GPU memory is 8 gigs and cannot run it even for batch size of 1 with 512 resolution. Now I got 2 GPU of 8 gig. How can I get for training? Thanks a lot. We do not support multi-GPU training, but adding these features should be possible. How to train a model on multiple GPUs. I'm very interested in your pSp GAN. I have two 1080 Ti. I want to know how to change the code to use them both. I tried to change the code of Coach from self.net to Torch and but it doesn't work. So I want to get some help from you. Thanks. And I wonder what kind of dataset you use. In our experience, we used a single P40. Okay, so P40 has 12 GPUs, so it has 24 GPU RAM gigabytes CUDA cores. Okay, so let's put some links, and I'll put the link to the Substack thing I mentioned before on the chat. Substack. And 550 links. All right, so I didn't remove the code of Celio. I don't know what code should be used instead. In our experiments, however, with some GPU, some adjustments, pSp should be able to run on multiple GPUs. Did you remove the line self-device CUDA 0 at the beginning of Coach? For working with multiple GPUs, I recommend exploring using distributed data parallel with PyTorch. There are many great tutorials online. At the moment, we do not plan extending support for multi-GPU training on pSp. I made the following changes in Coach, which seem to be working well. Self-device CUDA, self.net encoder. Okay. So let's say, yeah, I don't know if it works. I have a question regarding prefer a more complex model in parallel. Let's assume I have a GAN model with an additional encoder and some additional losses, as shown in the illustration. So two main patterns on how to use Torch and NN data parallel. One has been used in the Pixel2Pixel HD implementation from NVIDIA. As you see, they wrapped all the networks and losses and even optimizers on the whole model. Pattern 2, the other option is to call As you show this again, the settings more convenient, you don't have to deal with each regular multiple inputs after separating model from logging using their board X. My question is now, would you suggest to use one or the other pattern when using, let's say, 8 GPUs or a single instance? Okay, so the thing that I don't understand, so they use the network, so they use a graphics card, so like a RAM, so a GPU that has 24 gigs of RAM, and we have 2 of 16. So can we get Google Colab 24 GPU? T4 GPU. Okay, because nothing's being used. So right, so let's clone the network locally. So let's try that. So here, git clone. Okay. Cool. Allow multiple GPU, currently using CUDA visible devices. Right, so there is a to do here. So pSp ops to self device. Right, what we can do is like, let's try to go to coach and let's just make the changes. So we're gonna do here CUDA, selfnet encoder. Where do you do this? Okay, so where do we define a pSp? So pSp self opts. So pSp sets the encoder, so set encoder to self device. Not sure where to put this code. Probably you don't need to do this twice, right? Just put it here. Yeah, I also made the losses parallel. Right, so let's just try with this. I don't know what's gonna happen, but we don't lose anything for simply trying. And I'm gonna do that in the coach. Right, so we save that and we're gonna simply try to run again the training. All right, let's see. I don't expect this to work, honestly, because it's just like two simple changes, but it would be good. Oh, Moco loss. All right, so it would be good if this worked. Okay, so probably just put this here. ID loss. All right, so right, once again, we go into here. Okay, we have the terminal here, which I didn't see the other day. So it's right below here. So you click on your terminal and this opens, which is a fully fledged terminal that you can use to navigate. All right, so let's keep going. So I go to here, I copy this, I open the code again, I save that code, and I go to training. Where can we get a wow. All right, that's not working. Okay, so I'm trying to solve this bug here, and I'm not sure if I'm gonna be able to, but we'll stay here for a bit. Okay, so we can overwrite, but I don't know how to write a new variable. So it's environment, set default torch. Hmm. Okay, we're getting another data loader. This data loader will create 8 worker processes. All right, let's try to reduce that to see if that doesn't complain. But size 1 workers 4. Okay, let's read more here. All right, so we don't see anything of like training data of like how they train this. Hmm. I don't think these guys. I don't think these guys are gonna have more than 16 gigs, right? Okay, I don't know. Maybe this fixes it. Now we've changed the code. I'm not sure if the code changes I did change anything. I think this is just because I changed the batch size. And we have less workers. All right. This is training. All right, so we've got to somewhere, but I would like to discover why this is. Is it because of the code? Is it because of the the changes we've done on the training setup? I'm not sure. We should probably try that. Okay, so that's training, which is awesome, and the RAM usage is not bad at all. And let's see, we get the terminal here. Can we run this thing? Oh, okay, so we can run things here while the thing is running. So memory free. So okay. Great. So this keeps running and we are training. Okay, so we said we were gonna save interval 5,000. Okay, that seems like a lot of time. Nah, maybe we save every 250 or something, or every 500. Well, let's put it to 200 for now so we can see something. All right, so we have the change code in here. So a few things we've changed. So the first thing I'm gonna do, I'm gonna reset everything. I'm gonna reset to the factory settings. We're gonna try to see if with the new code that I set there, we can train without making any changes to the code, just using one GPU, I guess. And we're gonna clear all output. This is still running, but I'm killing. Okay. So we got a fresh new runtime. Or not. Let's do factory reset. Yes. And we're gonna reconnect. We're gonna see that the files are empty. We're going to clear all outputs again. We're gonna remove this thing here. And we don't need this at the moment, but I'm gonna keep it above here just in case. Or maybe let's keep it where it was. Let's keep it here, comment it out so it doesn't run. And now we have another fresh runtime, and we're gonna run everything. So for now, I'm gonna close all of these things that we had here, opened, and yeah, so everything that Google Colab Pro offers seems to be 16 GB cards. This one, I don't know what that is, if that's a TPU or where that comes from, but let's look for that. Probably a CPU. I don't know. Not sure. Right. See what's going on here. Everything's downloading and we are training, and I forgot to set this. Save interval. Let's put this here. Let's put this like this so we see something. Right, let's do a training run of 1000. Factory reset, reconnect, clear all outputs, and run all. All right. While this is going, I'm gonna open the Discord in case there are any messages in there. And all right, let me see. Nope. All right, so we have this thing is training. Okay, so what we're trying right now, right? What this experiment is about is, let me see what's going on here. All right, so this should be now starting to train. And if everything goes okay, the experiment we're doing is that we have a clean repository copied on the Colab machine, and we've only modified the path of the datasets. We're using the same dataset for testing and for training, which is not great, but you know, that's just because I just want to make sure that we can run the training notebook. And we're going to see if by setting the batch size to 2 and the workers to 4, if this machine is able to train this algorithm without giving me the CUDA memory allocation error in PyTorch. Later from there, we'll have to maybe increase the batch size and increase the workers just to see how the algorithm performs and if this actually can train here. Something that makes sense, because maybe a batch size of 2 is not great for this algorithm to be trained with, but we can read more on that on the GitHub repo of the researchers who did this paper. Let's actually go to that, and let's actually add a title. And so this would be Pixel2Style2Pixel pSp training. And this is gonna be let me just copy the repo here. All right, so how's this going? Awesome. So we're gonna get a checkpoint in a second. So we're going to get a checkpoint probably in our experiment folder. Haha, 250. We got the checkpoint here. So timestamp. All right, and we're getting the checkpoint with the value. So loss seems to be going down. Loss ID. Okay, I don't know exactly what these values mean, but we're gonna let this run. And I guess this is probably overfitting on the data that we have because we only have 100 images, but because we have another notebook that they provide for inference, maybe we could copy the code or open the notebook, opening Colab. And yeah, Rob, we got a checkpoint. I mean, we're training now, so I don't know how well it's working with the batch size or anything, but the important thing is that we're actually training. So it's good. After 3 live streams, we got to it. And yeah, so this goes through setting up the experiment type. Yeah, so I guess this would be just one of these checkpoints that we will be able to replace in here, and we'll be able to perform an inference with it. All right. So I'm gonna take a quick break. We're not gonna go for long today, but at least we solved this issue, and we're gonna get another breakpoint now. So at 500 we're gonna see the validation happen, and at 1000 steps we'll stop. All right, checkpoint. Probably saving now, I guess. Oh, images. Test. Train. Faces. Okay, so it's actually generating the images for the iteration before saving the checkpoint, and then it saves the checkpoint. So we don't even need to do anything. So we can see our images are here. Wait. So each 500 steps, it's validating. Oh, okay. So at the amount of steps that we set for validation, it actually runs the entire test dataset through the network. Okay, so this is pretty cool because I mean we have almost all the code set. Great. So this is actually already learning. Not a lot. Oh, I mean, it is learning. 13. So where is 1300? All right. I guess we need to leave this training for a bit more, right? Otherwise, we're not going to see anything. All right. So we'll get another validation checkpoint at 1000 we might stop here today, because I think we covered what we needed, and that way we don't make the live stream super long, and we can start from here next week and we can play, or maybe I'll do another live stream earlier, who knows. I'm gonna wait until this goes up to 1000 and we'll see the validation images, and yeah, we'll probably comment a bit and go. So let's put this here. So we're gonna see these steps showing up here. I'm gonna disappear for a second. Let me see how this is showing. Okay, so I'm gonna disappear for a second. Yeah, and we'll be back in a bit. Okay, so it seems like this has finished. Let's see what it's done for us. So we have, so this is not running anymore. So step 950, and I'm not sure if we're gonna get more, more validation images. Okay. So the model stopped right before we have this checkpoint here. And what can we do? Validation, how can we? I guess we could use this as a checkpoint. So like try to use this as a checkpoint instead of what we have right now. So that's something that we could do. Let me Well, first, let me download these ones to make sure that we keep them. All right, so we do have, so that's a good idea. So we do have these pre-trained models here. And I could replace my checkpoint for this model and yeah, I'm not sure if that's what it is because this model is meant to be always the same. So probably what changes is this one. Hmm. Right. Did we download any of the checkpoints? Yeah. All right. On the meanwhile, so we don't lose any time. So I'm gonna put this to 5,000, and I'm gonna tell this to maybe to make it more fun to validate every 200 steps and save the model every 200 steps, just so we have more stuff. We still have a plenty amount of disk, and we're going to, so let me see, live 49, and let's see what the original amount of batches is. Intermission, yes. And yeah, so let's see, initially we have batch size of 8. Let's maybe change that to 4. Let's see if that works. Batch size. All right, so let's rerun this. We're downloading these models, and oh, they're 1.12 gigs, so maybe we can cancel the download of some of them. All right, let's just download this one, or let's use our terminal. All right, so let's go to Pixel2Pixel. Inside of experiments, we have this first one and a new one that just started. Let's see if this works. It's frozen. Okay, let's open a new one. Yeah, not sure what's going on, but this is frozen. Let's close this. All right, so we are training again. We're going to be saving every 200 steps. We're going to be saving images like this ones. We can go already to this folder here. Probably we got the experiment folder. Everything's a bit frozen on this Colab notebook at the moment. Yeah, probably because I was trying to export files from here and it didn't like it. Okay, let me actually stop this. Let's do a factory reset. It's okay. And let me actually reload the page. Right, so we're gonna keep this, but I don't think we've seen that we don't need it. So this is 50. Move the pixel thing to 50. Move 50 folder to live, and in live. All right, we have stuff. All right, so we are going to connect to a high RAM runtime, and we're going to connect and run all. And yeah, what I expect to see is just those checkpoints. I would like to download one of the models to be able to see it on Netron, to see the neural network architecture, just in case that we can see and relate what the model is to what's on the paper. And I don't know if this was here before. GitHub. Okay, and all right, let's close things because this is going a bit slow now. All right. Run all. Okay, so we're gonna run everything now, and we're gonna check the images. Maybe, I mean, let me. I'm changing my mind a lot, but let me actually make it, because we're not gonna be. I don't want to spend a lot more time today. I have to go, and we are gonna set this to 100. So we'll be seeing a lot of checkpoints, and that's probably better. Right. So factory reset, reconnect, clear output, and run all. All right, and yeah, because I want to see a lot of those, so we can maybe try to see or infer the transition between the different epochs and what the model is learning. And yeah, I don't really know. So we're trying to train a model that learns how to do the Stalgan inversion. So to find an image that looks similar to that inside of Stalgan. And yeah, I don't know how that could be, because do those images need to be on the network? I guess the outputs do. We need to understand a bit more about the datasets. That's like we need to watch the videos and see. I'm trying to think, how would we train like a sketch to face, for example? How would we train that? Would it be like the image of a sketch and then the photo, the real photo from the network in the Stalgan that we've trained with Stalgan? Because if we have a network with Stalgan sketches, right? What do we get on the left, right? What we get as an input of the network? Okay, you said downloaded wrong, so we can download again and download Stalgan again. And this probably downloaded. Okay, so let's try training. Right, so it's training now. We're saving every 100 steps. Yes. So we should be seeing the experiment here. So this is here, checkpoints, iteration 0. All right. Let's see. Images, train, test. So what happens here is that we have the input. We want to find this image on StyleGAN, and we get this, which is the kind of the default StyleGAN image that is being retrieved with what we have, which is, you know, the output of the encoded W plus. The W plus vector is always the same regardless of the input that we give it. But what we're gonna see now is that this output image starts resembling a bit more to this as we move forward and we train. So I don't fully understand the process of like how this is testing, but you know, we'll keep going. So okay, so we've restarted and we have here now step 100. All right, so now for step 100 is grabbing the images and so some images are only, you know, we can see 0, this one here twice, right? So this barely changes, but it does change a bit. Okay, so let's open maybe 4. Okay, this is what we opened before. Yeah, it's moving, but it's almost nothing. So we get here step 100 twice, which I don't fully understand. There's something weird going on with the validation code. Oh, okay. So this is train and this is test, and the test runs only on the validation steps. So yeah, that's what we'll see. And then on 200, we'll get 200 twice as well. Okay. All right, 1 second. Let's see. All right. Yeah, I mean, I think we've seen how this is doing it. I don't have a way to make this faster right now. And I guess we'll just have to inspect the results afterwards. What I was trying to do before was going to the models folder. So Pixel experiments, and then the second folder. Then we get checkpoints, and then we go there. And I just wanted to see like if the model would be too big if we zip it. And that will show up here. Because right now this is 1.12 gigs, and I'm not sure how big the zip file is going to be. Just maybe it would be good to download one and be able to open it in Netron today. All right, so this is going, it's on step 300. Okay, so where is this going? 500 megabytes already, so you can see here. All right, and we're in step 350. And this is gonna be, this is gonna turn into 400 soon, and we'll see another checkpoint. So we have, oh, okay, so we actually have every 100. So we do have this one as well. You see the background at least is lighter and this is darker. So it's, it starts to get some features, right? So we deflated 8%. So we get this 200 zip model, which is a bit smaller, not too small, but I don't know. Let's just download it and see. The easiest way for this, which we've done before, is just to copy it to Google Drive. So mount Google Drive and copy it there. That's a lot faster. I mean, it's super fast. And then from Google Drive, you can download really, really fast. This will take ages, but if we wait, maybe we can get one model that way. Right, 400, 400, 400. Are you here? Let's close the terminal. All right. This is definitely much, much better. This is like really, really different than what we had before. So, because I love animations, so we're gonna save at least this one. We could save all of them if we had this as automated code, but we don't. So I'm just gonna make an animation on this. And how is this? Right. Okay. Okay, so we got the thing here, and oof. That's really good. All right, so what we got? We got This last moment is super, I mean, it changes a lot just in one step. Okay, so yeah, and I think, I mean, Stylgam mainly has frontalized images, but they probably do also like sideways. All right, 500 test. So we're saving images here. 500, where are we at? Oh, wow. That is crazy. Okay. I feel it's worth waiting, right, to make a GIF. And yeah, hello Suje for connecting. Okay, so nice to see you online. All right. So desktop frames. I'm gonna go to desktop. I'm gonna make it there, which is animation or maybe just GIF, and move all of my JPEGs to the GIF directory. And all right, so we got GIF. So I'm gonna make a make file to make a GIF, and I'm just gonna say, okay, convert, delay, everything that is on frames, the JPEG, and we're gonna save it as animation.gif or Pixel2Style2Pixel.gif, and then we make GIF. Well, we actually make the frames directory and move all of the JPEGs there, and now we make the GIF. And we can actually hide this, just a make file tip. If you put this at, and we can say echo making GIF, or instead of making exporting GIF, make GIF, and then and we also need to silence this one. So make GIF, exporting GIF. That's it. All right. Oh, so GIF. It'd be good to get the file name so we see the steps at which each is made. And I think we can make this a bit faster. So maybe like that. Make GIF. So for GIF making, I use Image Magic, which has an awesome tool, command line tool for anything, for like image manipulation and stuff. So it has a lot of commands. So for example, I can get all of the frames here, and I could, I don't know, I could go there, and I could use another image magic tool that is called Mogrify. And let's actually move this here. So I could say Mogrify to the PNG format, so convert everything that's JPEG here. So now it's gonna convert all of these images to PNG, right? So PNG and JPEG. Or I can say Mogrify everything that is JPEG and do a resize of 25%, so they get reduced in size. Right, so now these are super small. I could rotate, I could resize to a given size, so maybe let's make them super big, even though now they're pixelated. And I can do this to force the proportions. right? So force the proportions would mean like if we do this, right? So they get squeezed because usually they maintain the aspect ratio. I don't know. There's a lot of stuff that you can do with image magic, and I use it more and more. I don't know. Probably you can do Mogrify, rotate, 90, everything that's JPEG, right? So we rotated those images, and so we can keep rotating. Yeah, it's super, super nice. I recommend learning a few commands because it's super useful. All right, so how's our model? Now we waited and a lot of more images are generated, so we should automate this GIFing process and have that done automatically. Now we have where we were at 600, 500, right? 500. So we can probably do it like this. It might preserve the names. Yep, so it preserves the names. And that way we don't have to be renaming them. So now we go to GIF, make GIF, open again. And we got it here. Ha! All right, so after step 700, the hair grows and it really looks like in the image. So I guess like if we wanted to make a super smooth transition, we would, oh, and the face in the bottom starts to look like that one. All right. Yeah, these conversions are pretty cool. We should make a lot more of them. And I mean, I guess we can simply, cannot multi-select, right? But I can do this. Right, so here I'm just moving images, and we're gonna make the GIF again and open the folder, and let's see. Okay, yeah, I guess at the end we want to see more detail, so maybe just put it here. All right. Hey Rob, I use one of the free online websites that pop up during Google search for most of my use. Yeah, I mean, you can also do that. Probably they use image magic in the background. And yeah, okay. I'm gonna leave this training for a bit just to see how many steps we need to go to get a decent model. This is still downloading, so this is, you see how slow this can be to download large files. And let's see the latest. So 900. Right now that is starting to look good. The chin and color of the, yeah, these might not get it. Are we gonna get maybe a beard here? Oh, look at the clothing. So we're already getting some clothing there. Okay, this was fun. I'm so happy. I'm so happy that this worked and that we didn't have to go with our like empty-handed. So we have 800 here and 1000, and I'm gonna share, so 800 as well, and 800. All right, so we use, okay, so we can actually just move and make GIF and open when it's done. All right, so yeah, I guess we can end here, and I'm gonna share the GIF to the Discord so you guys can see it as well. I don't think, okay, so here. Oh, lateralization. All right, so in step 900, we start seeing that the face goes a bit to the sides, right? So it moves and it gets located as the this is really crazy. Okay, we got the GIF. And yeah, this keeps, we can keep going forever until this ends, right? So I'm gonna stop here. I'm gonna share this GIF there, and just to let people what we did. So I'll say here, oh, to style to pixel training on Google Colab. The back, so the error went away by reducing the bat size and the amount of workers used. All right, and here's a sneak peek of where we got to. All right, so let's see, we just, okay, and we put this here, so Pixel2Style2Pixel. All right, let's actually tweet that. Yeah, I mean, if the comment of sticking with it comes for me, yeah, I mean, I'm trying to be consistent and thorough on the experience we do and not leave many things open, if that's what you meant, or at least I understood the comment that way, Rob. And then I'm just gonna put this on Twitter and share this. Okay, so encoding in style. the pSp network, trace an encoder to generate a VW when fed. So training steps while training a Pixel2Style2Pixel encoder on Google Colab. On Google Colab. Training steps while training. Right, how do we make this shorter? and I see a comment here on the chat. So Rudy Giuliani freestyle videos. Oh, just go here, but going to start from the beginning if you plan on leaving it up. Yes, I'm. We're gonna go in a few minutes. So yeah, feel free to start from the beginning, and I'd love to see you maybe live next week around the same time as today. All right. So training steps of a Pixel2Style2Pixel encoder. Learns to generate W plus Stalgan latents from input images in search of the corresponding Stalgan image. All right. Do we know the people who made this on Twitter? Do they have a Twitter account we can name? Yuval Alaluf Twitter. Hmm. All right. All right. And one thing just to double check. Oh, we have the model as well. Let's unzip that. Okay, so right. Wow, that's fast. um, Message maybe. Can we do that? All right, enough Twitter. So we got the model here, and we're gonna open it with Netron. The model is 1.2 gigs here on Mac, and I'm gonna close all this stuff, and we're in step 1900. Oof, we've got really far away. And yeah, as I've mentioned before on the live streams, this is Netron, and this allows us to see all of the layers of the model. But you know, with this big model, it's probably not too formative. We just, yeah, probably not. Okay, we'll have to export some other diagram. Right, so we have these things. So last thing we can do is we're going to pass here the force, and I'm gonna close it up. 1, 2, 3, 4. Right, so what we've seen what this does, right? And for you to understand the process, what this is doing is at these points from 1900, for example, so this checkpoint allows us to generate a map, an image to the latent space of StyleGAN. And okay, let's run this one last time. We haven't downloaded this one, right? Okay. Okay, so just to see it by hand, let's say, so we open it manually. We are here. And you know, this is sort of cheating because we're testing with the same images that were on the dataset. So we shouldn't be doing this, but anyhow, we now got a second version of the GIF, and this is gonna be it. All right, thanks a lot for those of you who connected live with us or that are watching it offline. We have a lot more videos. This is live 50. We didn't do anything special, but you know, we'll keep celebrating every week. And yeah, I hope you enjoyed this. I've learned a lot. I hope you too. It's taken us 3 weeks to actually manage to train this properly. It's probably not that hard, but you know, you need to find the files and the settings and the solve the errors and things like this. And yeah, so without further ado, I'll leave. I'm going to record a quick outro for the working session that we might edit and upload to the intelligence and sketching playlist. All right, so this was one more session of the intelligence and sketching playlist. You can watch more videos like this one at Nono.MA/YT or on the channel, right? Okay, let's remove that. You can watch more videos like this one on the intelligence and sketching playlist. You can go to youtube.com/Nono Martinez Alonso and find them there. Thanks a lot for watching, and I'll see you next time. And yeah, for those of you who are online, I won't tell you anything else. This has been it. Yeah, and Suje, Rob, Rudy, and those who couldn't connect today, so DVS, Ricardo, and Vitor, and many other people, Juanda. Thanks for being there. I'll see you next time. Bye. And now I have to disconnect. All right, I'll disappear like this. And does the camera look good? We have a different camera today, which is great. I think this looks so much better. Bye. Still here, but disconnecting. Goodbye. Thank you, guys.